Welcome to the third video of our little mini unit on vectors. I'm going to be talking about vector addition again, and really it's something that we already started in the previous video. We're going to be concentrating on adding vectors by using components. So here's an example. When vectors are all either vertical or horizontal, it is easy to add them. They're already in that head to tail kind of method. They're already arranged that way, so my resultant would actually start here and end way over there, which looks a little crazy. Another way you could look at this is you could say, well, I'm going to add all the horizontal ones. 7 and 5 is 12, so I could say this is the same thing as saying 12 this way and 5 that way, and then it just gets a lot easier to the diagram's a lot easier, and we can figure out using Pythagoras what this side here is. Using our trig, we can figure out what that angle is. So we're going to take some practice now, starting with an existing vector and resolving it into components. This is what we use the verb resolving when we break things down into its components. So just an example of using that language. Let's replace a vector. In this case, we're going to call it t in this sentence with its horizontal. And that would be the x direction, and vertical, that would be the y component. This is known as resolving a vector into its components. So here is the vector, and here would be the x direction and the y direction. So if this is a tension force, I'm going to use the letter T because this is what our example is. So I'll say this is Tx and this is Ty. So if we were to think about our diagram here, we'd say, okay, the cos of 40 degrees, cos is equal to the adjacent over the hypotenuse. So in this example, the adjacent would be my x direction, and my hypotenuse is 60 newtons. Or I could also just say what the tension force was to begin with was at 60 newtons. So my x would be equal to 60 multiplied by the cos of 40 degrees. Similarly, I won't compute it, I'll just leave it there. Similarly, my y direction here, maybe I'll switch to green here. My y direction, I would be using sine, because the sine of 40 degrees is equal to the opposite, which is the y component of tension, divided by 60 newtons with a hypotenuse. So Ty is going to be equal to 60 times the sine of 40 degrees. Okay, I just want to point out this pattern here. So when my angle, when I'm measuring the angle off of the x-axis or the east-west axis, we have this pattern that x goes with cos and that y goes with sine. So here's what I wrote down here. I said, note, if the angles are in counterclockwise from east, then you can follow this pattern where the x component is equal to, now this part here where I write, that just means the magnitude. That's like the number part. So in our example, that would be like this 60, right? Because this was the magnitude part of the vector. So the magnitude multiplied by the cos of theta. So let's try this out. We're going to do a little practice here. It says find the x and y components of 40 newtons at 30 degrees counterclockwise from east. Okay, so let's see here. 30 degrees would be in that direction. Here's my 40. Here's my 30 degrees. So what I'm going to find is, I'm going to find this x. Maybe I'll get a different color for it. Maybe I'll say this is my x. And blue, this will be my y. So when I'm figuring out the x direction, I will be using cos. I will say cos of 30 degrees is equal to x over 40. If I multiply both sides by 40, I will get x is equal to 40 times the cos of 30 degrees, which is just what I meant up here. right? So I could actually take that shortcut right away. If I plug that into my calculator, I guess I get 34.6 newtons. For my y direction, I'll say here that, well, it's the opposite side, so I'm going to say that the sine of 30 degrees is equal to the opposite over the hypotenuse. So when I solve for y, I'll say y is equal to 40 times the sine of 30 degrees. You may happen to know that the sine of 30 degrees is a half, so I would get 20 and the units would be newtons. Okay, so that's how I would do this question. Here's another one where I say 15 meters per second at 100 degrees counterclockwise. Well, let's think about this here. So if I write 100 degrees is going to be past 90 degrees. Okay, so it would be over there. I'll try to draw that better. So it would be this way. So this is my 100 degrees. So now let's just take this pattern, this here, and let's just follow it and see if it works okay. So I'm going to say the x direction, so the x direction in this case was actually going to go negative, isn't it? So in my x direction, I'm going to say, well, let's even say ax is equal to, I'll call this vector a, is equal to 15 multiplied by the cos of 100 degrees. Feels kind of strange to put in something greater than 90 degrees, but if you're familiar with the unit circle and all that, you're gonna say, well, this should give me some value that's a little bit negative. When I use my calculator, I'm going to get negative 2.6, and my units are meters per second. Isn't that nice just to figure that out so quickly, just to type it in there? And how about my y direction? So in my y direction, I will say 15 times the sine of 100 degrees. So it's a really nice quick shortcut. And the y direction is going to be quite large, a little bit less than 15. It works out to 14.8 meters per second. And that seems pretty reasonable given my diagram. Okay, so let's try this next one here where I've got 20 degrees south of west. Okay, this way's south, this way's west, so 20 degrees would kind of be this direction. So if I want to use this shortcut, I have to change it into counterclockwise from east. So this 20 degrees is here, so counterclockwise from east would be 20 degrees plus 180 degrees, that would be 200 degrees. So I could rewrite this and say 10 meters at 200 degrees counterclockwise from east. Then I can follow that same pattern and I can say, okay, so my x direction is going to be equal to 10 multiplied by the cos of 200 degrees, and my y is going to be equal to 10 multiplied by the sine of 200 degrees. Looking at this, my x should be fairly close to 10 and should be negative because it's going in the left direction. My y value should be quite small and also should be negative. So when I use my calculator, here I actually get negative 9.4, and my units are meters. And for my y direction, when I type in my calculator, I think I get minus 3.4 meters. So you can check that out on your own if you'd like. Okay, so you can see how quickly it is to figure out the x and the y components of things. Let's see about adding this one using components. So this one isn't very tricky. I'm going to say, let's call this one vector A, this one vector B, and this one vector C. And I'm going to say, okay, I'm going to think about all the x directions and all the y directions. And then I will say, I'll put the answer for the x direction of vector A here, and the answer for the y direction for vector A there, and here for B, here for C, and then I'll add these up, and I'm going to call the answer the resultant. Okay, let's see how this works out. So first of all, the x direction. Okay, looking at this one, there is no x direction. It's going straight north. It's going straight up. So I would say, put a 0 here. And my y direction is just going to be +5. So far I haven't used any trig. Looking at B, it's going to the right. So that's a +9 here. And it's not going up and down at all, so it's just a 0. Okay, so now I've got this C value here. And that C value is going at 45 degrees. 45 degrees, although it's not counterclockwise from east. So I'm going to look at C, and I'm going to put that into this counterclockwise from east notation. I'm going to say it is 14 meters at, what would this be? 360 would be the whole, 360 is a whole circle, but it is 360 minus 45. That makes sense. So 360 minus 45 would be 315 degrees. Okay, so my values here, this one would be 14 times the cos of 315, and this one would be 14 times the sine of 315. So, by the way, when I put those in my calculator, I think that this would be the same thing as in the x direction. This is going to be plus 9.9, and this one is going to be minus 9.9. You can try that out on your calculator and see how it works. Okay, so now thinking about the resultant. So we've thought about our resultant before, and we could say, okay, if we're starting here and we're ending there, here's my resultant. What this method does is it's going to tell me how far is this in the x direction. So in other words, this will be the x component of my resultant. This will be the y component of my resultant, and this will be my resultant. So if I add 0 and 9 and 9.9, I guess I get 18.9. So that is the x direction, and the y direction is going to be these ones added together. 5.5 and negative 9.9 will give me negative 4.9. In other words, if I just consider these two, I'm going to have an x. Again, I'm going to draw my x first. Here's my x of 18.9. Here's my y downwards. That's because it's negative of 4.9. And so this is my x component of my resultant. This is the y component of the resultant. And this is my resultant. So really when I'm talking about the big idea here of how do you add vectors using components is you add up all the x components of each of the vectors, and that will be the x component of the resultant. You add up all the y components of each of the vectors, and that will be the y component of the resultant. And so at this point we need to, well, we don't want to know just the x and the y, we want to finish this off, and it'll be just like we've done so many times before. We're going to use Pythagoras. So r is going to be equal to the square root of the x component squared. Well, here maybe I'll make it more familiar. I'll say c squared is equal to a squared plus b squared. So the resultant squared will be equal to, in this case, 18.9 squared plus negative 4.9 squared. I don't really have to put the negative in there because it's going to get squared. Another way to write this is to say r is going to be equal to the square root of rx squared plus ry squared. In any case, my resultant in this case is, what did my math say? 19.5. And what about the direction? Okay, so here I will say that theta is going to be equal to the inverse tan of, now the opposite sides is always going to be the y component, and the adjacent side will be the x component. Something important here is I'm going to put in, even though this is downwards and I got a negative here, I am going to put in just positive values to begin with. I'm going to put in 4.9 over 18.9. I'm just going to sort of highlight this by saying that here means absolute values. Use only positive. So even though there's a negative here, we don't put the negative over there, okay? So, and I think you'll see why in a second, so I'll just put that over there. So when I do the inverse tan of 4.9 over 18.9, what do I get? I get 14.5. Theta is equal to 14.5 degrees. Now we're not quite done because I have to sort of interpret that and say, all right, so that is 14.5 degrees here. So what is that? Now I have to think about if x is positive and y is negative, I'm in quadrant 4. So what is my heading using counterclockwise from east? Because it's in quadrant 4, it's going to be 360 minus that 14.5. And so I'll get an answer of 345.5 degrees. So I know I kind of encroached on the next question, but I'll say I got to state my answer somewhere. I will say my total answer for this question is going to be 19.5 meters at 34.5 degrees counterclockwise from west. Okay, so sorry for using up all that space. I'm going to stop now for this video, and I think that's enough for you to do the sublevels. Sublevel 3, I think you did already. So if you didn't do it, you should still do that one. And I think for sublevel 5, when you type it in, you can use, what's that called, a start code when you're doing the mop. You can use VCR, and I think I actually put that into your the sheet for you to track things. Okay, so two things. You can start off by doing these worksheets, and I've got the sheets there, and there's answers to go after that, and then you can do the Minds on Physics sublevels 3 if you haven't done it yet, and 5. All right, and that's probably a good place for you to do next. I'll make another video later to do these last couple examples. I want to keep it short. Okay, so I'll see you in class.